Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on electromagnetism and magnetic fields from May June 2022, paper 4, variant 2. In this question, we will discuss forces between two wires. Means when two wires are placed like this, parallel to each other, how they exert forces on each other. Are those forces attractive forces or repulsive forces? And we will also discuss some other important points about electromagnetism and magnetic field in this lesson. Watch this video carefully and try to improve your conceptual understanding of these topics. Let's study together. Let's improve together. For question number 6, part A, we need to state two conditions that must be satisfied for a copper wire placed in a magnetic field to experience a magnetic force. Let's try to understand this one with the help of magnetic force equation. And this question is simply asking us, if you place a wire in a magnetic field, when wire will experience a magnetic force. So simply we can understand this one with the help of magnetic force equation. FB means the magnetic force is equal to I times L times P times sine of theta. And theta is the angle between B and L. Now we need to understand, if I is equal to 0, it simply means that there will be no force on the wire. And if sine of theta is equal to 0, then also there will be no force on the wire. Sine of theta, if this is equal to 0, it simply means that theta is equal to 0. So if theta equal to 0 or current equal to 0, there will be no magnetic force on the wire. And simply these 2 points we have to mention in our answer. Mean there must be current in the wire. We can say must current in the wire, and also wire has to be placed at non-zero angle. So simply you can say non-zero angle. Then wire will experience a force. So simply we can mention these 2 points and you will get 2 marks. So this is how you can write down your answer. First point you can say there must be a current in the wire, and the second point you can say wire must be at a non-zero angle to the magnetic field, because theta is the angle between B and L. If you mention these points, you will get 2 marks. You will get 2 B marks. For part D, it is given to us a long air core solenoid is connected to a power supply, so that solenoid creates a magnetic field. Figure 6.1 shows a cross section through the middle of the solenoid. So imagine that we have the solenoid like this, and we cut this solenoid from the middle, means from the center, and this is what we will see then. So these are the wires, so these are wires, so these are the wires. It is also given to us direction of the magnetic field at point W is indicated by the arrow. 3 other points are labeled X, Y, and Z. For part B1 on figure 6.1, we need to draw arrows to indicate direction of the magnetic field at each of the points X, Y, and Z. So first of all, in order to answer this question, we need to understand magnetic field around solenoid and magnetic field inside solenoid. Magnetic field inside solenoid is uniform. So this is the first thing you need to understand. B inside solenoid is uniform. So we can write down B inside solenoid is uniform. But B outside of solenoid is not uniform. As B inside solenoid is uniform, as you can see here, the lines, magnetic field lines inside the solenoid, these lines are at equal distance from each other. So the magnetic field has to be uniform, so it means magnetic field has the same magnitude and magnetic field has the same direction, because inside magnetic field has only one direction, and that is to the right. Means the same, you don't need to follow this, you need to follow this one. It is given to you, it is to the right. But this solenoid, magnetic field of this solenoid and magnetic field of given solenoid are the same. So this has magnetic field to the left, so at point X magnetic field also has to be to the left. left. And the magnitude of magnetic field is same. So the length of arrow has to be the same and it has to be in the same direction. Now we need to understand magnetic field at point Z. At point Z, you can see if magnetic field lines are here, you can see these are pointing to the right. So you can draw arrow here. This arrow has to be to the right. And this magnetic field has to be weaker than magnetic field inside solenoid and also magnetic field at this point. Because here magnetic field lines are dense, it means magnetic field is stronger here as compared with this one. And at this point, magnetic field lines are at an angle of 45 degrees. So here simply you can draw the arrow pointing upwards at an angle of 45 degrees. But we also need to consider the length of the arrow. So this arrow has to be a bit smaller than the arrow at the center of the solenoid. So this one has to be a bit shorter, but it has to be longer than this one because magnetic field here is the weakest because lines are further away from each other. So this is all what you need to understand about magnetic field inside a solenoid and magnetic field around a solenoid. You have drawn these arrows in the right way, you will get 3 marks. And this question has 3 B marks. For the second part, we need to compare the magnitude of the flux density of the magnetic field at point X and at point Y. We have already discussed magnetic field at point X and at point W, means at point X and at point W is almost same, is approximately same. Because magnetic field inside solenoid is uniform. So simply we can say magnetic field at point X means the magnetic flux density. This is approximately equal to magnetic flux density at W. And for the second part, we need to compare at point Y and at point C. Means at this point and at this point. We have already discussed magnetic field at Y is stronger than magnetic field at Z. So simply we can say magnetic flux density at Y is greater than magnetic flux density at Z. So that's all what you need to write down. This question has 2 marks. So this mark is 1 B mark and this is second B mark. So this is another B mark. Let me show you the answer. This is how you can write down. So simply you can say in this case flux densities are approximately equal at point X and W, but at point Y flux density is greater than flux density at C. So this is how you can answer. For part C, it is given to us 2 long parallel current carrying wires are placed near to each other in a vacuum. We need to explain why these wires exert a magnetic force on each other. We can also draw a labor diagram if we wish. Means it is optional, not required. Let's try to start answering by sketching wires. Imagine that this is wire A and current in this wire A is to the right. We have another wire and current in this wire is also to the right. So simply we can write down this is current and this is wire B. Now we need to find out force on one wire due to another wire. So we need to understand magnetic force FB is equal to ILB. In this case, this B you have to be clear. This is the external magnetic field, not due to the same wire. So I is current in the wire. If you are talking about force on wire A, so this is current in wire A. And B in this case will be the magnetic field of wire B. Let's try to find out force on wire B by wire A. So we can say by wire A. So we have to find out this force. In order to find force on wire B, we have to consider current in wire B, the length of wire B, and we need to consider magnetic field due to wire A. So this is BA. So these are the points you need to understand. Now let's try to find out magnetic field on this side of the wire. Means at the lower side of wire A. In order to find magnetic field, imagine that this one is the wire. This is our wire A. In this wire A, current is flowing to the right. We need to find out direction of magnetic field at the lower side. So in this case, you have to place your hand. So you have to find magnetic field here because other wire is placed under this one. So you have to find magnetic field under wire A. So you have to place your right hand. Thumb has to be pointing towards direction of current. So current is to the right. So if you place your right hand, you will see under this wire, magnetic field is pointing into the page. But above this wire, magnetic field is pointing out of the page. But we are interested only under this wire. So we can draw magnetic field here. So magnetic field under this wire is into the page due to wire A. So we can also draw some crosses here. So magnetic field under this wire is into the page. Now you can see from here, this wire is inside magnetic field of wire A. So this wire B will experience a force. You can also understand if magnetic field you go from this point to this point, means away from the wire. You need to understand magnetic field is equal to B is equal to mu naught I over 2 pi r. As you go away from wire A, magnetic field has to get weaker. But we are not talking about these things. We're just talking about magnitude, means the force, why this will experience a force. We are not talking about the exact magnitude. If you need to calculate, we can also use this formula and we can calculate. If you want to use this formula, for example, in this case, you will get this is IB and here you have LB. So the B will be equal to mu naught IA divided by 2 pi r. And r is the distance between these two wires. So you can calculate magnitude of magnetic force as well. But in this case, we are only interested why this will experience a force. We don't need to calculate magnitude. Now you need to imagine this wire B is inside a magnetic field. That magnetic field is into the page. So let me draw in a different way so you can see the clear picture. So let me use different color. Now you need to understand we have the wire and the wire is inside external magnetic field. External magnetic field, I can write down the B. This external magnetic field is into the page. So I will write down EXT and this magnetic field is into the page. We have magnetic field that is into the page and current in the wire B. This current is to the right and we need to find out force on this wire. So we have to use Fleming left hand rule. So we have to use Fleming left hand rule and we can find out direction of force on wire B. So in this case we have magnetic field that is into the page, means this finger is pointing into the page and current is to the right. So the force on wire B is upwards, means this force will be attracted. So there will be attractive force on this wire upwards. So this is the force on B by A, and there will be force on wire A as well, action and reaction forces. So that will be pointing down, means these two wires, they will attract each other. So we can say force on A by B, that force will be pointing down. So this is what you need to understand. Simply you need to understand when this wire B is placed inside external magnetic field, and in this case external magnetic field is due to wire A. So the wire B will experience force by wire A, means these two wires, they will attract each other. In this case, if current is in the opposite direction, they will repel each other. Magnitude of this force on two wires will be the same, but direction will be opposite. So that's all what you need to understand. So let me show you the answer, how you can write down the answer. If you have any questions about this one, just leave your questions in comments. I will answer as soon as possible. So let me show you the answer. This is how you can write down the answer. And this question has 3 marks. If you have written these points, you will get 3 marks. Current in wire. Current in wire. In this case, we are talking about current in wire A creates magnetic field. And that is also true for B. B will also create its own magnetic field because current is flowing in wire B. Current in wire creates magnetic field around wire. Each wire sits in the magnetic field created by the other wire. We have discussed this point. If you need to find the force on wire B by A, you have to consider magnetic field of wire. For each wire, current is perpendicular. That's the reason we haven't used sine theta here, because sine of 90 degree is equal equal to 1. So that's the reason we haven't used sine theta here. They are perpendicular because current is here, magnetic field. So you can see current is this way, magnetic field is this. So the angle is 90 degrees. Current is perpendicular to the magnetic field due to the other wire. So experience a magnetic force. So this is how you can answer this question. I hope this is clear to you. If you have questions, just feel free to leave your question in comments and I will be answering as soon as possible.